Alrighty. Now, this is Calculus 2. We're finishing up 1.5 notes. Finding the limits at infinity or going to infinity, so there's certain things that we're actually going to try and look at. Now, when we're doing these, there's a nice, pretty little cheat to this. Okay? And so, what's the degree of the top? What's the degree of the bottom? If they have the same degree, use their coefficients, the numbers in front. So it would be, so I use this because, now, the reason for that is the highest degree means that it is, once you're going towards infinity, and you're talking about ridiculously large numbers, all the rest of this really doesn't matter. What's infinity plus 1, right? Okay? Those numbers really don't matter. They're insignificant. So all the rest of that's not going to matter. So these, with the x squared and x squared, so infinity squared and infinity squared, they're both going up at the same rate. Okay? The same rate. So if it's going up at the same rate, that means that the x squared over x squared, so the infinity squared over infinity squared, will be able to cancel out, and I'm just going to be left with my coefficients, the numbers out front. So I'm going to be left with 3 over 1 in this case. Does that make sense?
Yeah.
Yes, it says plus to infinity, but once we're actually getting, infinity squared, it's going up so much more. Okay? It's going to dwarf what just infinity is. Infinity squared is. Okay? Yeah. I know. We're talking about like ridiculous nonsense things, right? But yeah. Okay. Now, looking at these two right here. Okay. Are they the same degree?
No.
No. Which one's going up faster?
The bottom.
The bottom. Now, remember when we were talking about bigger numbers on the bottom. What's going to happen with bigger numbers on the bottom? It gets what?
Yeah, smaller.
Keeps getting smaller, smaller and smaller and smaller, right? Okay, so as it keeps getting smaller and smaller and smaller, okay, once I get so big that close to infinity, that this number is just dwarfing this other one, okay? So this one is going to be going out to 0 because the number on the bottom is going to be that. Now, I want you guys to graph this second one so you guys can see this. So we have 4x squared minus 5x over x cubed, right?
Yep. Plus 1.
Like that. Okay. Enter. Okay, so now, if you look, okay, it's going this way, right? Going out here. So, looks like it's going somewhere. All right. So, let's try and put in some numbers. Turn on trace. Trace graph. Let's go with -10. Okay, there's a really, really small negative, right? Okay, let's go to -100. Okay, keeps getting smaller and smaller, right? -1,000. So -1,000. If you notice, it keeps getting smaller over here too, right?
Yeah.
So as I keep getting smaller, it's eventually going to what? Remember, this is E, so this is scientific notation. It's times 10 to the -4. So that means that there is 4 zeros in front of this, right?
Yes.
Okay, so, or 3 zeros in this case. So it just keeps going and keeps going. So if I put a ridiculous number So we're basically on 0, right? Yes. So as it keeps going over here, it gets me to 0. Now let's look at it from the other side. What if I just do a positive number? Hey, look, way over here. Now it's back up on the other side. So what do you think it's going to go to on the positive side? It's also going to be 0, right? Does it look like it's going to be going to 0? Yeah, okay. So this one right here is going to give me 0. All right, so find limits at infinity. Now, okay, what did I say matters? What's the cheat? Look at the front, right? So if I'm only looking at the front, that means it's this and this, right? So I'm basically only looking at, right? Because this, meh, as I go to infinity, I keep getting bigger and bigger, right? So what's going to happen here now? Okay, what's square root of 4x squared? What do we get? Say it. 2x over x, right? So now as I take that to infinity, I'm just going to get 2. Okay, you got to be careful with the radicals right here, okay? So radicals, yes, you can try to do that first part right there to see if it will work. You could even test it too. Put it in the graph. Take it to positive numbers, right? Positive infinity. And see what we get. All right, so let's see next one. All right, so you guys can play with that later. All right, so right here, other infinite limits at infinity. Now, for this right here, as x approaches negative infinity, so of e to the x, so negative infinity, so now on this side, the left-hand side going to negative infinity is going down to 0. Okay? Mm-hmm. Now, e to the x to positive infinity goes to positive infinity. So it just keeps going up. That's all it's saying. It goes up to positive infinity. It keeps going up all the way. Okay? So at infinity, this goes up to infinity. So it goes to infinity. Yeah, let's wait for that. Come on now. All right. Other limits at infinity right here of ln x. Now, right here. Now, can I do negative of this graph to negative infinity?
Yeah.
Say no.
No.
As it approaches negative infinity.
I thought you meant as it approaches negative. Like, could you determine where it's going?
Yeah.
Well, yeah,
Okay.
it's the 0.
Okay, because it's never, it's going to stay here. It's outside of my domain, right?
Yeah.
It's outside of my domain. So I can't actually look at this from this side because I don't have that domain. I only have from 0 to the right. Okay, so now this right here, from this ln x to infinity goes to infinity. Okay, it's going to constantly be going up slowly, but it's still going up. Okay, application, decomposition of salt in water. Okay, yes, okay. So, chloride, sodium, blah, 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 decay. Okay, here's the decay rate that we're going to use. Okay, what's A sub naught? The original amount, okay. You guys probably have had chemistry, right?
Yeah, something like that.
Okay. K, okay, so since this is a decomposition, K is a negative number that represents the, oh crap, you know what? I'm trying to use a mouse instead on this one because I'm trying to stay out of the way. Okay, K is a negative number that represents rate of dissolution. Why is it a negative number? It's going down. Okay. So if we're doing like what's the microorganisms or whatever, like bacteria. Okay, that's like exponential growth, right? Okay, so that would be a what type of number? That would be a positive for that, right?
Yeah.
Okay, that's what we're looking for there. That's the point we're trying to get at. So if it is a growth, it would be a positive. It's a decay, it's negative. Okay, A of t is the time amount in kilograms of undisclosed salt present time t hours. Okay, so that basically took care of everything. If initially there is 25 grams, okay, 25 grams, so what does that represent? A sub naught. A sub naught. Okay. It's I don't know why they call it A sub naught. So that's your initial amount. Okay, of undissolved salt after 10 hours. Ooh, hours. What does that mean?
Time.
Time. Okay. And don't forget, right here, time is in hours, so make sure your units match. There are 15 kilograms of undissolved salt remaining. How much undissolved salt is left after 1 day? Okay, so, yeah, okay. So, if there's initial, okay, initial, 25 kilograms, right? Okay, so that means that that's gonna go my A sub naught, right? Okay, so I think I have this broken up. No, okay, so my and T is 10 hours.
Right, yeah.
What else do we have there? Okay, so initially 25 kilograms undissolved, 10 hours. And there are 15 kilograms of undissolved at oh wait, no, 10 hours is the 15, sorry. My bad. All right. Oh wait, that was right. Dang it, that was right. Okay. I hate word problems. 25 and T is T, so this is 15 when T is 10, right? So these go together. And this is my A of T. Okay. So my formula was A of T equals A sub naught e to the K T. All right, so we're going to fill in some values here. Initial. What's my initial going to be?
25.
Okay, so I have a point there, don't I? Okay, what's my time at initial? 0. Okay, so I get A of T is 25, right? E to the K of 0. Right? Okay, so that's 0, my time. So A of 0 equals 25. All right, so now let's do the other point. So the other point over here is going to be A of 10 is going to equal 15 e to the K of 10. Okay? Alright, so, oh crap, I put something in the wrong place. Why'd you guys let me do that? You guys let me do that. Don't let me do that. 25 is initial, right? And 15 is my A of 10. There you go. I'm not very good at chemistry, so that's why I always put these in the wrong place. All right, so my initial amount, A sub naught, 25, that was my first, right? Initial, here's here, time, I come out with here. So I'm trying to solve for K, right? As soon as I solve for K, then I can actually put that back in my formula. So I know I'm going to have, divide that out, so it's going to be 15 over 25, right? So e to the 10k equals 3 over 5, right? Okay, keep going with that. Okay, so I'm trying to get k by itself. So it's going to be, how would I undo that?
Natural log.
Okay, so natural log, so I'm going to ln, but I got a fraction there, right?
Yes.
Okay, I got a fraction there, so this would be ln, so it'd be ln 3 over ln 5 equals, that's going to be 10k, right? And this is ln 3 minus ln 5 equals 10k. I just separated it.
Yeah.
You guys remember
Yeah,
log rules? Yeah. If it's a division, it's minus sign. Okay, divide both sides by 10. So k is, I'll let you guys do the math on that one. What do we get?
Negative 0.05.
Yeah.
Negative 0.051. What's the next number? 0. Okay, it's fine.
There.
Three's good. Okay. AP calculus test, remember it's always rounding to 3 decimals, okay? So we have a k value, right? Okay. So there's my k value. I have my initial value, and now it's asking. So I have everything. I have my t from my next problem. So the next problem, so if k equals negative, what'd you say?
0.051.
Okay, my t, what was the t that it asked for? What? 1 day, so that's 24. And my initial amount? Okay, let's plug it back in now. Right, so we're going to say that a of 24 is going to be equal to 25 e to the negative 0.051 times 24. Calculate. What do we get?
7.351.
Yep.
So a of 24 is about 7 point.
351.
And what are my units on this one? Of salt. Right? Okay. Okay, how much undissolved salt is left after 1 day? How long will it take until 12 kilograms, so here's my new initial amount, of undissolved salt remains, okay? So, I want to know when there's 12 kilograms left, okay? So let's go back. So I want this function to equal 12, right? So we're going to solve for t in this case, right? We're looking for time. So I know that on this next one, I want this to be a of t is, I don't know, and I want that to equal 12 kilograms, right? So I'm going to say 12 is equal to 25 e to the negative 0.051 of t.
Now you do the same thing to find t.
Yeah, do the same thing to find t, right? So from here, I would get,
Divide.
yeah, divide it out, right? So it's,
Natural log again.
so it's basically going to be ln of 12, ln of 25, all over negative 0.051 is equal to my t.
Plugging it in right now. 14.3.
What is it?
I did it, I just had a line, I had a graph for the function.
Oh, okay.
Instead of line to 12.
So you said what?
14.392.
Does that seem right? So at 24 hours, there's 7 grams left. Yes?
Mm-hmm.
And at, what was the other one?
10.
At 10,
It was
at 10, there was how much?
15.
15. Okay, so does that seem right? Okay, it does seem right, right?
Yeah.
So at a certain point, it actually slows down the digression. So make sure it's actually your parameters are in there. So if I know at 10 it's 15, and I know at 24 it's 7, intermediate value says somewhere in between there, your time frame has to fit, right? Yeah.
Let's say on the AP test, it's like the no calculator portion. Could that just be my answer?
Yeah.
Natural log 12 minus natural.
Yeah, but they're, you know, they would have this as your answer. It's fine.
Okay.
Okay,
Just
so whatever they might even give you the, you know, the rate of regression there.
Mm-hmm.
So, but yeah, that's fine. Okay, remember what they said. Okay, don't factor it or anything. Okay, just leave it messy. Okay, because if you go through and simplify, you might screw it up.
Yeah.
Algebra mistakes are where it's at. Okay, so let's see. Find as t approaches infinity. As t approaches infinity.
Zero?
It should be going to 0, shouldn't it?
Yeah, I don't think it would go.
E to the power of infinity.
Yeah, right.
Yeah.
So it's going to approach 0 for this one. Okay, so eventually all that salt is going to be dissolved. Okay, it's going to be very, very salty. More salty than my class after I gave them a crap load of homework. All right, horizontal asymptotes of a graph. Y is equal to L. Okay, horizontal asymptote of graph function are x unbounded in the negative direction, right here. Okay. For this one, the line y equals m, the horizontal asymptote of the graph of a function for x unbounded in the positive direction. Okay. M. Okay, so we have an upper bound and a lower bound right here. So we have horizontal asymptotes, keeping it in between there. This looks like a function of like inverse tangent function. Yeah, it's an inverse tangent function. Either way, so it's going to be bounded in between here and here. Find horizontal asymptote of that graph. So where do you think the asymptote is going to be?
2. No, wait, no.
Okay, so now, yes, we got enough time to do this, but watch this. Okay, you see what the problem is here, right? Okay, you see what the problem is?
Yeah.
So I'm going to show you in the graph, and you're going to tell me what the rule is going to be on this. Because this always helps me remember this. So on top it was what? 3x what? 4x minus 1? Okay, so we're going to which side, positive or negative? Did it say positive infinity or negative infinity?
It doesn't. It's like, I thought it said like, hey dude, where's the?
But ours shows
It just says find the horizontal axis.
Yeah,
Yeah.
this is find it.
Mhm.
That asymptote.
Okay, so the asymptote means it's approaching something, right? Okay, so where's this one at?
3/4, man.
3/4. Now, if I look at my thing, okay, so of the graph here, is this the right graph?
No.
Okay,
Oh, it isn't.
so now you guys see it. Okay, it's not this graph. Okay, sorry about that. So asymptote is 3 or 4. Okay, same degree. That's what we get. Any asymptotes of the graph right here? Where's this one going to be? 3 halves. Is there any vertical asymptotes? Any place in which that this is going to be equal to 0 in the denominator? So you basically take the bottom, set it equal to 0,
Start.
and do the math there, right?
Yeah.
Okay, so I'm going to keep going. And so on top, it would be 3 quantity x squared. Keep trying to avoid doing that. Okay, x squared minus 4. So if you factor the top, you get an x squared minus 4. So that should help you also. So if I have an x minus x squared minus 4, so if I have an x plus 2 or an x minus 2 here, I know you're paying attention, not playing on your phone, right?
Yeah.
So if I have that here, what would happen if I could actually cancel out one of those? The x plus 2 or x minus 2, what would happen if I cancel one of those? It would be a hole, not an asymptote, because it's a removable discontinuity. Okay, that's important. Okay, so when you're factoring it, you have to look at the top also. All right, okay, and there we go. Don't forget, like and subscribe, right? Share it with your friends. Notification, hit that notification, and there is, okay, for only people watching this one right here, so there is going to be a Loot Crate prize stuff giveaway at the end of the month, okay? So there is some Loot Crate prizes at the end of the month, okay? As long as, you know what, if this video right here gets 100 views, I'm gonna take one of my subscribers and I'm going to give them a Loot Crate prize. All right.